Hello. Hello.
Hello? Yes.
Yes, ma'am.
Yeah, go
Hello.
on.
This is Hindi. Hello. Hello.
This session will be in English.
Hello. अच्छा मैम ये जो उस टाइप इंक्लूड रहेगा दो टेस्ट 23 फरवरी जो एग्जाम है
I cannot properly hear you.
आई वांट टू से upcoming exam 23rd February. This
Yeah.
exam include week 5
No, it
content.
will be week 1 to 4.
Ma'am, I cannot found any PYQ question except math. City also I cannot find a PYQ. It is an English. Three
Uh, s-
subject में.
PYQ, I cannot help with the PYQ. Maybe you can ask your other classmates. They might have. Or
Please,
you can check out the revision sessions from previous terms. There we have discussed PYQs.
ये के discuss होता है मैम.
Sorry?
ये PYQ discuss होता है.
Yeah, yeah, in the revision session for quiz 1 qualifier, okay?
मैम ज्यादातर क्वेश्चन कहाँ से आता है गेटेड असाइनमेंट से आता है ना पीआईक्यू से
No,
आता है.
no, questions will not be like repeated kind of. It will be similar type of question, but not exactly the same question. So you can check out the revision session for weeks 1 to 4. You can find that
Ma'am,
in the YouTube channel.
मैम प्लीज इसको
ma'am, in
डेटा ये
previous
कहाँ पे मिलेगा.
examination, both many of the question are repeated from PYQs.
पीआईक्यू.
Yeah, but some values might have been changed, or if you find some repeat questions, maybe some few
नो नो
questions might be there.
पैटर्न ऑल्सो पैटर्न मिलेगा तो सुनेगा. क्वेश्चन वर्ब नहीं
Yeah,
मिलेगा नहीं
uh,
चाहिए.
for uh, for PYQ discussions, you can just check out the YouTube channel and find the previous term sessions. Okay.
मैम नहीं
Ma'am,
मिलेगा
which
नहीं
channel?
नहीं कहाँ से मिलेगा मैम.
Ma'am,
देखो
Sorry. Yeah.
Ma'am, sir, ask age grade. Is the website available PYQ from 22,
eighth grade.
22 to
I
eighth
think
Eighth
I
grade
think
total?
grade.
uh, I think they should be available. I'm not entirely sure where you can find the PYQs, but I will discuss
Yes,
PYQs
ma'am.
in the
We will
revision
solve
session.
this question.
Yeah.
Available, ma'am.
Okay, so if other people have the PYQ links, just share with them your classmates so that everyone can get it. Okay.
anyone listening for YouTube में चाहते हैं.
Just go to the IITM BS degree channel, YouTube channel. There you can find the playlist for CT. Okay. Rest of you please mute. All right. So today we will start week 4. Okay. So first let me do the summary of whatever concepts are there. So main thing in week 4 is about binning. Okay. So that is the main concept for week 4. So we'll discuss the summary or the theory part first. Then I'll discuss some of the practice questions. Rest of the practice and activity questions will be taken in the other 2 sessions for this week. Okay. So let me share my screen 1 second.
Ma'am, please start the class.
Yeah, just a second. I'm sharing my screen. Is it visible for everyone?
Yes,
Yes.
ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So, see, why we use the concept of bins is because we want to reduce number of comparisons. Now, where does this comparisons come from? So, if you have gone through the lectures, so you will see that there is the concept of nested iterations, right? Nested loops. So, we have seen that kind of question where there is a while loop inside a while loop. So, those are called nested loops. So, whenever we do nested loops, like for example, let me just say I write a pseudocode like this, that while there are more cards in file 1. Okay. So then inside this, I'm writing that pick a card. Now, if I want to compare, let's say this is from the scores data set. Okay. So scores data set has all the student information, right? So if I want to compare the physics marks of all the students, okay. So what can I do? I can first pick one card from the file 1, and then I can compare that card with all the other cards in that file. Right. So when I pick that card, when I pick the first card from pile 1, so that card is removed. So let's say there are 30 cards in the beginning. So once I pick a card, now there are 29 cards left. Okay. So I have to compare this card with all those 29 cards. So once you pick a card, then you write again that while there are the same thing, more cards in pile 1. Okay. And then here you can write the comparison code. That let's say you pick the card X here. Now this X card you will compare with all the other cards in left in pile 1. That is all the other 29 cards. So these are called nested iterations. Okay, so this is a loop within a loop. Now when we do this, so how many comparisons will be there in total if I want to compare every student with every other student? So how many such comparisons will be there? So every person needs to be, if there are 30 cards in total, so one card needs to be compared with 29 other cards. Yes or no? Hello, am I audible?
Yes, ma'am. You're audible.
Okay. So if I pick one card from the 30 cards and I need to compare it with 29 other cards. Now this process I need to do for every single person in that file. So how many total comparisons will be there? 30 into 29, right? Every person will be compared with 29 other people. So there are 30 total people. So 30 into 29, that many comparisons. So this is a big number of comparisons, right? Now, how can we reduce this number of comparisons? So here is where the concept of winning comes from. Bins mean what? That instead of having this one pile of 30 cards, okay, we'll have multiple small piles. Let's say maybe 3 cards each or 5 cards each. So if I take 5 cards each, then there will be 6 piles. Now within those 6 piles, inside those 6 piles, I'll do the comparison. Now let's say I divide this 30 cards into 10 piles having 3 cards each. Okay. Now inside this one pile of 3 cards, if I want to compare every card with every other card, then how many comparison will be there? So let's say I have cards A, B, and C. So A needs to be compared with B and C. Again, B needs to be compared with C. So do I again need to compare B with A? Or is A with B the same as B with A? Look, you have to answer, okay? This is not just me talking. So when I ask, if whatever you feel like, you just answer. So if I compare A with B, is that the same as comparing B with A?
Yes, ma'am.
Right.
No,
So I'll compare A with B once. I'll compare A with C once. And I'll compare B with C once. Okay. But I don't need to compare again C with B or C with A. So total of how many comparisons do I need inside this one file having 3 cards each? 3 comparisons, right? So see,
Three.
this is how we can reduce the number of comparisons. So if I have 3 comparisons per file, okay, and there are 10 such files, then what is the total number of comparisons? 30. So that's a huge decrement from this number. Okay. So this is the basic concept of binning. So let's now take some examples to understand this. So the main reason why we do binning is to reduce comparisons. Now, what we observed is that some computations seem to require more comparisons with each card. Okay. With all the other cards in the pile, like I said. So you pick one card, you have to compare it with all the other cards. For example, if you want to choose a study partner for each student, so each student should have a study partner. So how many comparisons will be there? So you have to compare with every person based on some criteria. If that criteria matches, then these two people can be partners. So for that, I need to go through the entire pile. So this is a huge number of comparisons. Now we observe that if we can organize the cards into bins based on some heuristic, that means some criteria. Okay. So what can be a criteria? Maybe I can pick the date of birth as a criteria. That okay, all the people born in February will be in one file, all the people born in January will be in one file. Okay, like this I can create 12 files for 12 months. Now inside that I'll place all the people who are born in the same month in the same file. So that can be one criteria. Okay, in that case, every file will have a much smaller number of cards. So the number of comparisons will be significantly reduced. So what is the formal way of determining the reductions? That how much am I reducing the comparisons? Right. I need to know the exact percentage or the exact number by which the comparisons are being reduced.
नहीं नहीं नहीं
So
जाएंगे
first we have to calculate the number of comparisons without binning. For that, what do we need? We first compare the entire file with each other without doing any partitions, any separate files. We just keep one file of cards and do all the comparisons and see how many we need without using binning. Okay. Next, I will calculate with binning that, okay, now if I distribute these cards according to some criteria like date of birth, like I just said. So I create 12 files, each one for 1 month, and each file will contain the students who are born in that month only. Now I do comparisons inside each of those files. So that will give me a total number of comparisons again. So once I find these two, now I can easily find out that by how much of a factor the comparisons has been reduced. Up to this, is it clear for everyone?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Now see, this example will make it much clearer. So let's say I have 5 elements A, B, C, and A, B, C, D, and E. Okay. So I have to compare each element with every other element. So how can that be? So maybe I'll first start with A. So A will be compared with B. This is one comparison. I'm just writing down the comparisons here. Now B, okay, now A will be compared with C also. So now this is two comparison. A with D also. A with E also. So A is having total how many comparisons? 4. This many comparisons for A. Now for B. Now come to node B. So node B will be compared with node C. This is one comparison. Again, B needs to be compared with D. B needs to be compared with E also. But do I need to compare B with A again?
No, ma'am.
No, ma'am.
No. So
No,
A
ma'am.
to B and B to A. Right? These are same for comparison purpose. So for A, I have 4 comparisons. For B, I have 3 comparisons. Now try for C. So for C, do I need to compare with A or B?
No,
See,
No, ma'am.
there
It's
ma'am.
are
already
incoming
compared.
edges. Yes, incoming edges are there. That means it's already compared. So you compare C with D. There is no edge from C to D. Again, C with E.
Two comparison.
So C will take 2 comparisons. Now for D, D only it is connected with all the nodes except for E. So D to E there will be 1 comparison. Now come to E. Does E need to be compared with anyone?
No, ma'am.
No, ma'am.
No,
So for
ma'am.
E will have 0 comparisons. So what is the total number of comparison I need? 10. So for 5 elements, I need 10 comparisons in this manner. So this is without binning. Okay, I'm taking all these 5, just think of it as like 5 cards in a pile. So this thing is only written here. The total of 10 comparisons. Okay. Now, what is the actual formula? Like now I have 5 objects, so I wrote it down. But you might have n number of objects, n can be a large number. In that case, it is not possible to draw this graph, right? So there is a generalized formula. The formula is that for n objects, the number of comparisons will be 1 summation of 1 from from 1 to n minus 1. So how does this formula come? So what did we see for A? I had 4, B I had 3, C I had 2 comparisons, and D I had 1 comparison. For E I had 0 comparisons. So for 4 objects, so where n is equal to 4, I'm sorry, n is equal to 5. I have 5 objects, A, B, C, D, E. So how many comparisons am I needing? 1, 2, 3, 4. So if n is 5, then 4 is n minus 1, right? 3 is n minus 2. So like this, I went up to 1. So just summation of these comparisons is the total number of comparisons. Now this is nothing but sum of natural numbers. So what is that formula? Normal sum of natural numbers formula is what? N into n plus 1 by 2. Okay. Just instead of that n plus 1, you do n minus 1. Because we are doing up to 1 less, right? We are not doing up to 5. So this n minus 1, I will be comparing up to n, I'll be adding up to n minus 1. So the formula will come n into n minus 1 by 2. So for this example, if you put it in this formula, what is n? N is 5. So 5 into 5 minus 1, that is 4 by 2. So that is 20 by 2, 10 comparisons that we got. Right? So this formula is very important. So if you have n number of objects, total number of comparisons without binning will always be n into n minus 1 by 2. Okay. Now, you can also use the combinations formula. Okay. If you cannot remember this, then you can also try this NC2. But this also evaluates to the same value. If you do NC2, this is using that combination, permutation combination formula. Okay. So if you evaluate NC2, one second. Just turn it off now. Just give me a second now. Some people are making noise. Yeah. So if you evaluate this NC2, that will also come up to n into n minus 1 by 2. So any of these you can remember it by. I think this is the easier one. So from first principles, so how this is evaluated. So once again, let's find out how this formula is reduced. So total number of comparisons, total number of pairs is how many? If I have n elements, then if I take 2 at a time, right, that is NC2. So out of n elements, I am finding how many combinations can I get where I pick 2 elements at a time, right? That is NC2. So total number of pairs is n cross n. If I have 5 elements, how many 2 element pairs can I have? 5 cross 5, right? So this n cross n. Now from this reduce self comparison. Self comparisons means A compared with A itself. So is that a valid comparison? Do I need that?
No, ma'am.
So reduce all the self comparisons. So if there are n number of elements, how many self comparisons will be there? If I
It's
have 5 elements, how many self comparisons will be there?
5.
5. So if I have n elements, I'll have n number of self comparisons. So total number of pairs is n cross n. From there, I'm reducing all the self comparisons. So n cross n minus n, right? Because those are redundant comparisons. So that can be written as n into n minus 1. Just take n common from this. Okay. Now, since we know that comparing A with B and B with A is the same thing, but that is calculated here, right? Here it is calculating all possible pairs. So it is taking A comma B as well as B comma A. But we know that these two are same. So this is happening for every single pair. That means number of comparisons should be reduced by how much? Half, right? So that's why we have n cross n minus 1 by 2. So this by 2 is to reduce all the double comparisons. That is, if I have A with B, then I don't need to have B with A. So that one comparison I'll reduce. So this will be reduced for every single pair. So if total number of pairs are n into n minus 1 after reducing the self comparisons, then I have to divide it by 2 to get all the distinct comparisons. So this is where the actual formula comes from. Okay, using first principles. Up to this, any doubt?
No, ma'am. No, ma'am.
Okay, all right. So you can write it like this also, half into n into n minus 1. So you see, number of comparisons can grow very fast. Okay, it can grow like exponentially fast as your n increases. So if I have two elements, then I have only one comparison. Three elements, I have three comparisons, like I showed you with that ABC example. For four elements, I have six comparisons. Now, see, up to nine, it is doable. 36 comparisons, 10 also 45 comparisons. But as soon as I go to the three digits, as soon as I reach 100, there are almost 50,000 comparisons, right? So, when you are using this in a program, okay, that's why whenever we write a program, nested loops are not very desirable. Although we have to use it in many cases, there is no choice, but nested loops can really increase the time complexity of your program. Okay, because the number of comparisons increase. So you are comparing n elements with n elements. So n cross n, that is n squared. Your time complexity becomes n square, order of n squared. So this complexity will keep on increasing as your number of elements increase, and that can increase very fast. Till two digits, you have doable comparisons. As soon as you go to three digits, 100 elements, you have 50,000 comparisons. When you go to 1,000 elements, you have 5 lakh comparisons. To see how it is increasing very fast, right? So that is our job, that how can I reduce this number of comparisons? So this is the quadratic curve. See, if this is n, okay, how fast it can grow. So this is almost growing like almost in a straight line, not exactly a straight line, but yeah, it is increasing, we can see, right? It is climbing. So how do we reduce that? Now we will use the key idea, that is binning. So if I have 9 objects, A, B, C, D, E, F, G, H, I. Okay, so for these 9 objects, if I don't do any binning, then how many comparisons will I need? What is the formula? Anyone tell me the general formula that we just saw?
N
N into n
minus 1
minus 1 by
divided
2.
by 2.
N into n minus 1 by 2, right? So for 9 elements, that will be 9 into 8 by 2. That is 36. This many comparisons. Now, if I do binning in this case, so I can bin the objects into 3 bins having 3 objects each. Think of this as like buckets. Okay. Each bucket having 3 objects in it. So one bucket has ABC, one has DEF, one has GHI. Now let's find this for bucket number 1, 2, 3 separately. So if for bucket 1 I find, how many comparisons are there in bucket 1? So again in bucket 1 we will use the same general formula, n into n minus 1 by 2. So what will be the value of this? 3 into 2 by 2. So how many comparisons? 3.
3.
3.
So for all 3 buckets total, how many comparisons will be there?
9.
9.
9 comparisons, right? But we still compared all the elements. So 36 was there without binning, 9 with binning. Okay. These slides are just showing the same thing, the total 9 comparisons. So the number of comparisons reduces from 36 to 9. So it is reduced by a factor of 4 times. Now see, these bins are not created just like you cannot create them based on whatever you want. There is some criteria given. Okay. Based on that, you will use the binning concept. Like I said, date of birth can be a criteria. Or some marks can be a criteria, that people who have scored greater than 70 will be in one bin, who have scored greater than 80 will be in one bin. Like this, some criteria based on which this binning is done. Okay. Now, how much has the comparisons reduced from 36 to 9? So the factor by which it has reduced is 4 times. That is 36 by 9. So this page is very, very important, okay, for solving questions also, this particular slide. So let's see what we have seen so far. So for n items, we know that without binning, number of comparisons is n into n minus 1 by 2. Now, if we use k bins, like in the previous problem, we saw that 9 elements were divided into 3 bins. So k was equals to 3. So if in general, if I use k bins of equal size, now this is very important that bins are equal sized bins. Okay, that is all bins are containing the same number of elements. So number of items in each bin is how many? If there are k bins and total n items and k bins, then what is the number of items in each bin? N by k, right? So each bin has n by k elements. Number of comparisons per bin is what? If I have n by k elements, then what will be the number of comparisons in that bin?
Is N?
N by k into n by k minus 1 by 2. See, instead of this n, just place n by k now. Okay,
Yes.
this is inside a particular bin. I have k number of bins and total number of elements is n. And all the bins have to contain equal number of elements. So we know that each bin will contain n by k elements. If I have 9 elements in total, n is 9, and I have 3 bins, k is 3. And each of these bins have to contain exactly same number of elements. So number of elements in each bin is what? N by k. That is 3 elements in every bin. So inside every bin, how many comparisons are there? You only calculated 3 into 2 by 2, that is 3. So how is this coming? It is coming from this formula only. Half into n minus 1. Instead of n, now you place n by k. Because number of elements has now changed. Inside each bin, I have n by k elements. So half into n by k into n by k minus 1. That is in our example, half into n by k is how much? 3. Into 3 minus 1, that is 2.
So
So again, 3 comparisons
three
for each
comparison.
for each bin. Right. Now total number of comparisons will be, so half into k into n by k into n by k minus 1. So up to this we know half into n by k into n by k minus 1. This is number of comparisons in each bin. Into k, why we are doing? Because this is the total number of bins, right? So total number of comparisons we want to find. So basically when we did, when k was 3 and each bin was having 3 comparisons. So we did 3 into 3, that is 9 comparisons in total. That same formula is this, right? So 3 bins, so k is 3. Half into n by k is 9 by 3. Again, n by k here is 9 by 3. So once you solve this, this is the generalized format. So half into n by k minus 1. If you can't remember this formula, okay, no problem. You can just derive it. So you know that for each bin, this is the formula. N is just replaced by n by k. And you multiply it with k. That's all. So this is just a derived format. It's coming from this only. So no need to remember this particularly. You can derive it yourself. Now, factor of reduction. There can be a question that, okay, if I use binning and if I don't use binning. So in both cases, you find out the number of comparisons. Now you tell me by what factor has the reduction occurred? How many comparisons are actually reduced? So we saw that in our example, first we had 36 comparisons, then we had 9 comparisons. So we said 36 by 9, that is our 4. That is the comparison factor has reduced by 4. So what is the formula for that? Not every time you will calculate all the comparisons, right? So there has to be a generalized format. So this is that factor of reduction formula. So how do we derive it? Total number of comparisons without binning by total number of comparisons with binning. So without binning, the formula is n into n minus 1 by 2. So this will be the numerator, by the denominator will be this one. Total number of comparisons with binning. So half into n by k minus 1. So if you do this and reduce this expression, you will get this n minus 1 by n by k minus 1. Now, see, in your exam, it can be difficult to remember all of these, right? So just understand the core concept that I have n elements and I have k bins, and all the bins are of equal size. So my factor of reduction formula is that numerator will have total number of comparisons with binning, denominator will have total number of comparisons. I'm sorry, numerator will have comparisons without binning, denominator will have comparisons with binning. I'll write it down. So comparisons without binning by comparisons with winning. So this is what we have to find out. So no need to remember this. You already know the formula that without winning, the formula is half into n minus 1. And then by, so total number of comparisons with winning is same, where each bin has n by k elements. So half into n by k into n by k minus 1. And total thing will be multiplied with k again because there are k bins. Right? And this is n into n minus 1 by k. 2. So just solve this and you will get this generalized one. So I hope everyone can derive this, right? So don't memorize. Okay. So if you do for 9 and 3, you can see that if I put it in this format, so 9 minus 1 by 3 minus 1. N by k is 3 minus 1. So 9 minus 1 is 8, 3 minus 1 is 2, 8 by 2 is 4. So that is how much the number of comparisons have reduced by a factor of 4 times. So is this slide clear for everyone? Any doubt?
Clear, ma'am. Please proceed.
So this is only the summary, okay, nothing more. So the main concept we have is actually why we are studying binning is because in this week we have some problems on nested iterations, right? So that's why we are telling you how you can decrease those number of comparisons. But it's better if we do some questions now. Okay. So if you have any more doubts from the theory part, you can ask me anytime. Let me share the questions.
Ma'am, why can we use Beanie?
Sorry, come again.
Ma'am, why can we use Beanie in this topic?
Why can you use?
Yeah.
To reduce number of comparisons. That's the goal. See, bins are created based on some heuristic or some condition. So if you have a certain condition given to you, like in that birthday paradox problem, how we can use binning in that problem? Birthday paradox says what? That if I have a sample of, let's say, 50 students, then there is a criteria, then there is a probability that at least two of them will have their birthdays on the same day. Right? So this will happen, this probability will be there no matter how small our sample space is. Because there is always a probability that two people will have their birthdays on the same date. Now, how can I reduce the number of comparisons? If I do this without binning, in my scores data set, I have 30 cards. Without binning, if I do, to find that, okay, which two people have birthdays on the same date? Or what are the pairs of people who have birthdays on the same date? Maybe three people or four people have the birthday on the same date. So how can I find that out? For that, I have to check with every card in the pile, right? Each card will be compared with every other card. This is without binning. But now I can also create bins because I know that people who have their birthdays on the same date, they must have been born in the same month, right? Let's say I'm not worried about the year. I'm just comparing the month and date, day of birth and the month of birth. That's it. So I can divide the file into 12 separate files based on every month of the year. Now, in each of the files, I just have, let's say there is a January file that contains all the students who are born in January only. So inside that file, the number of comparisons is now much reduced because if I did this without binning, then I'll be comparing people who are born in January with people who are born in any other month in the entire pile. But now I'm just comparing January people with January people itself. So that is reducing the comparison. Is that clear?
Yes, ma'am.
Okay. So let's solve some questions. Now you can see that we won't be using exactly this binning concept in our questions, but in the activity questions, you can find questions on that. But yeah, when it comes to your graded assignments or your quiz 1, quiz 2, and term. Okay, not exactly these concepts are going to be used. So what will be used is the questions that we are going to discuss now. Okay. Activity questions, if you check out, you can find sums on these topics. So first question is that for which of the following situations is our a nested loop needed? Nested loop, I just told you in the beginning that it is a loop within a loop. So when you want to compare one card with every other card, you need two loops, two while loops. So tell me anyone try which of these options is correct.
Students to same birthdays.
Sorry.
Ma'am,
Tell
first
me the
option.
option. Yeah, option
So
A.
option
Okay.
one.
Any other option?
Option B.
Any other?
Option D.
D.
Option D.
D you're saying. Okay.
Option D, ma'am.
Anyone think C? All right. So A and B are correct. Okay. But D is not correct. So first let's see why D is not correct. So D is not correct. What is the statement? To find number of bills from the same shop from the shopping bills data set. So here what is the criteria? First, that the bills have to be from the same shop. Okay. So once I pick a card from my pile, I can just put an if condition to check. Let's say I'm checking for bills, total number of bills from Big Bazaar. So pick a card, then put an if condition where you check that if x dot card is x dot shop name, that is x is your card, x dot shop name is Big Bazaar equal to Big Bazaar. If yes, then you increment the count, otherwise don't. So see,
Ma'am, D option is correct. To find the name of bills from श- मतलब उसके नेम होता नंबर की जगह तो होता ना करेक्ट.
name means what do you want to find out?
मतलब
Okay, see one thing here.
we find out
Here are we
we
comparing
find
anything? First tell me. In this question, do we need to compare any cards with each other? I just want number of
तो
cards from the same shop, right? But for that, I don't need to compare two shops or compare two cards. That is not required. I just have to check whether a card is from a particular shop. If yes, then I'll increment a count. But no
ओके मैम
comparisons are
ओके
there. Okay.
ओके मैम
See, this
गॉट
will
इट.
be the code. So you first initiate a variable count and you initialize it with 0. Then this is the only while loop that is required. So you just once iterate through the entire file, and for every card you pick, you check whether the shop name is Big Bazaar. If yes, you increment count. That's it. But now for options B, A and B, why they are correct? So for A, the statement is that to find the pair of students who have the same birthdays. So that's the example we just took. So I want that, okay, how many such pairs are there who have the same birthdays? So first you need a variable count again. So this is going to store that number of pairs. Okay, so count is initialized to 0. Now while table 1 has more rows, you pick first one card X. After I pick the card X, I read it, I move it to a separate table. Okay. Now inside I need one more while loop. This while loop is to compare this X card with every other card in table 1. So you read the first card from table 1 right now, which is a separate card, so let's say Y, because X has already been removed. So now I'm going to compare X and Y, their dates of birth. Okay. So if I see that X and Y have the same date of birth, that means they are born on that same date, right? So I can increment count that I have found one such pair, XY, who are born on the same day. Now this X might have the same date of birth with more than one people. So in that case, count will be increased more than one times, as many times as the date of birth matches. So for this one card X, this inside while loop will iterate through the rest of the pile. All the other cards it will check. So as many matches as it founds, that many times the count will be increased. Once this is inner while loop is finished, you move this like every time one iteration of this inner while is finished, you move the Y card to a separate table 3, and then you again go for the next iteration in while loop, inner while. So as soon as the inner while loop is finished, you move all the rows from table 3 to table 1. Now why is this done? Can anyone tell me? Why am I moving all the cards back from table 3 to table 1? See, first I am
For
taking
another comparison.
right
Checking to the another
for
card.
the next comparison. Correct. So what I'm doing first, you pick one card X from table 1, read it, move it to table 2. Now this X card has to be compared with every other Y in the same pile in this table 1. So every time I read a Y, I check this if condition. If it matches, I increase count and then move the card Y to table 3. That is, I have checked X with this Y card. So I'm moving it to table 3, picking the next Y. Okay. So once I've gone through all the other cards, so now table 3 contains what? All the other cards, all the other 29 cards that I've compared X with. But I need to compare every card like that. So for X, all the comparisons are done. Now I have to go to the next X. So you have to move all these cards from table 3 back to table 1 because at the end of the inner while loop, right, for every iteration, at the end of the inner while loop, table 1 becomes empty. So you put all these cards from table 3 back to table 1. So just understand it like this. After the first iteration of the outer while loop, okay, let's say outer while loop, first iteration is completed. So table 1 has how many cards now? After I have moved back all the cards from table 3 back to table 1. So table 1 has how many cards? If initially 30 cards were there.
Initially 30, but now 29.
Now table 1 has
29.
29 cards. Table 2 has how many cards?
One card,
1.
ma'am.
And table 3 doesn't have any card. Right? Table 3 is again reset to 0. So now next iteration of this outer while, I'll pick one more card. X. As soon as I pick it, table 1 now has how many cards? 28.
28.
I read this card and I move it to table 2. Table 2 now has how many cards? 2.
Two cards.
The total number of cards always remains 30. Right? That should always be maintained. Table 1 plus table 2 should always be 30. So now once we enter the while, inner while. So now you have 28 cards in table 1 and I'm checking for the X that I have currently picked. So now this X will be compared with how many cards?
27.
28 only, right? Table 1 has 28. The X I picked, I read it and I moved it to pile 2. So 28 cards are still left in table 1. So this second X is going to be compared with 28 elements in table 1. Now once that is done, so all these 28 cards will have gone to table 3 at the end of the while execution, this inner while execution. So again, I'll bring those 28 cards back from table 3 to table 1 and pick one more card, X, third iteration. So now table 1 has how many cards?
27.
I have read this new card that I picked and I have moved it to table 2. Table 2 has how many cards now? 3 cards. Now this third card, this is the one that we are comparing with every other card. So this third card will be compared with how many cards?
27.
27 cards. This is the third iteration of the outer while loop. Now for fourth iteration, again I will pick one more card. So now 26 cards are remaining and there are 4 cards in table 2. So this fourth card will be compared with 26 cards. Like this, all the cards will be compared. So now you tell me, once the outer while has completed executing, that is table 1 has no more rows left. At that point, table 1 has 0 rows. Table 2 has how many rows?
30.
30 rows. So every card has been compared with every other card. So we need nested loop in this case for this option. Is this clear for everyone? Any doubt?
No, ma'am.
No.
Okay. Now let's see option B. What is option B? To find the pair of students who scored the same marks in physics from the scores data set. Right. We need to find the pair of students who have scored the same marks in physics. So what is the condition here? Physics marks. So this is what we are trying to find. So for this, I again need to compare every student with every student, right? Every 2 students, I need to compare their physics marks. So outer loop will again work the same way. It will pick one card, read it, then compare that card with every other card in table 1. So this is the exact same code, only the comparison has changed. Previously, we were comparing date of birth, now we are comparing physics marks. So if we find somewhere a match between physics marks, I will increment count. Otherwise, no. So it works exactly same as the previous example. Do I need to write the table 1, table 2 thing for this one, or do you understand this?
Hello, ma'am.
Anyone?
Understand, ma'am.
Understand, ma'am.
If
Hello,
even if
ma'am.
one person needs me to write, tell me, okay?
Hello, ma'am.
Yeah.
Ma'am, I just joined the lecture. There is a doubt. The card we move from table 1 to table 2, then
Yeah, that is the card we are comparing with every other card.
we consider the cards in the table 2 as a Y.
Table 2 card is the X card that we
X
have
card.
currently picked. Yeah.
And what we considering Y?
All the rest cards in table 1 with
Okay.
which we are comparing.
Okay. That's okay, sir.
Okay.
Thank you.
Yeah. So at the end of the inner while loop execution, all the cards will have been moved from table 1 to table 3. That's why we are moving back all rows from table 3 to table 1 for the next iteration of outer while loop. So this is how a nested while loop works. Okay. That is, if I have, let's say, n elements. Okay. So how many times will the outer while run? Just tell me this. If I have n cards, how many times will the outer while loop iterate? Outer while.
N minus 1.
N only. Every card I will pick.
Yes, ma'am.
Okay. Outer while will iterate n times. Now let's say for the first iteration of outer while. First iteration of outer while. Inner while will iterate how many times?
How it
N
is?
minus 1.
N minus 1 times. Second iteration of outer while. Inner while will iterate how many times? Now 2 cards are gone.
N minus 2.
N minus 2. So like this for the nth iteration of outer while.
Can you repeat this point?
See, when I do the first iteration of this outer while loop, how many times will the inner while loop iterate for that one outer while iteration?
N
N
times
minus 1 times.
N minus first outer value.
Outer while loop has picked one card, right? So now n minus 1 cards are left in table 1.
Yes.
So inner while loop will iterate how many times? N minus 1
N
times.
minus 1.
Similarly, for the second iteration of outer while loop, now 2 cards have been taken from table 1. So inner while will iterate how many times? N minus 2 times. Like this, outer while will iterate n times for all the n elements. Okay. Let's say I have 5 elements only. So for first iteration of outer while, inner while iterates how many times?
4 times, and for
4
inner
times. Inner will iterate 4 times. Second iteration of outer while, inner will iterate
will 3
how many
times.
times? 3 times. So like this, for third iteration, inner while will iterate 2 times. For fourth iteration of outer while, inner while will iterate 1 times. For fifth iteration, that is when I have taken all the cards out, will this inner while iterate any more times?
There will be no cards to iterate.
No cards left. So this while will be false. So while table 1 has more rows, table 1 does not have any more rows left. So 0 iterations for the nth iteration of outer while. Is it clear? This.
Yes, ma'am.
Yes, ma'am.
So these are
Yes,
the two
ma'am.
correct options. Okay, C and D are wrong. Why is C wrong? To find the number of words which have the highest letter count. So that means I just have to find the max letter count and see how many such words are there. So does that require a comparison? It requires to find the maximum letter count. And whichever cards match that letter count, I can just say that that's the maximum letter count. So you can just increment count. So this will be the code. Okay. So one while loop, you read it, update the letter count. Okay, you check whether the letter count is equal to max for this card. So max is initially 0. This is how we find maximum, right? So we first check that is it equal to max? Then count will be incremented. If it is greater than max, then max itself will be updated, right? As soon as max is updated, count will again be 0. Why? Because we have now found a higher letter count. So now I have to start all over again. But are there any comparisons between two cards? In this case, are there any comparisons between two cards?
Yes.
No, right? We are just taking the letter count. That's all we need. So you need to find whatever is the max letter count and how many cards are having that max letter count. That's all. But I don't need to compare two separate cards for this. I can just maintain a max variable which will contain the maximum letter count, and I have to see how many such words are there which have that max letter count. So no need for comparison between two cards. So no nested while loop. So only option A and B are correct. Okay, should we go to the next question? Any doubt from here? This is wrong, this is wrong.
No,
No,
ma'am.
ma'am. No, ma'am.
Okay.
No, ma'am.
So let's do question 2. The following pseudocode is executed using words dataset. At the end of execution, A captures numbers of sentences with at least 2 nouns that have at most 2 vowels. Okay, we need the number of sentences with at least 2 nouns and at most 2 vowels. So both these conditions have to be satisfied. Right? That means what? Both have to be satisfied means what do we need? And or?
And
And. So at least 2 nouns, at most 2 vowels. Now we have to choose the correct code fragment for this one. So A, first of all, we have these two variables. A is initialized to 0, C is also initialized to 0. Now while table 1 has more rows, read the first row from table 1. Now the first card that I read. So words dataset cards have what information in them? I have the word itself, I have the letter count, I have the part of speech and the sequence number of the card. Right. So I take the first card. Now I check what is the part of speech of that card. So if it is a noun, then next I will check that what is the number of vowels present in it. So what is our condition? At least 2 nouns and at most 2 vowels. So for it to have at least a sentence, to have at least 2 nouns, right? So for every word, we are going to check whether it is a noun or not. That's why the first condition is that part of speech is noun. Okay. Now, if it is a noun, then we have to check that, okay, does it contains at most 2 vowels? If it contains more than 2, then it is a violation. So that's why for every card that is a noun, this second condition we will check, count vowels for that card. That this word contains less than equal to 2 number of vowels in it. That is at most 2. If both of these are satisfied, then I will increment C by 1. Okay. So how many such nouns do I need in my sentence that have at most 2 vowels?
More than 2 or 2?
At least. That means 2 or more than 2. Right. 2 is the lower bound. Either 2 or more than 2. So C will be incremented when the word is a noun and when the vowel condition is also satisfied. Now, next if condition is saying X word ends with a full stop. That means you have reached the end of the sentence. Okay. If C is greater than equal to 2 at that point, what does this C greater than equal to 2 signify? What does this mean? When will C be greater than equal to 2? If I have reached the end of sentence and I see
If,
that C is 3, that
ma'am,
means what?
if it will contain the part of speech, words having part of speech noun and count of vowel more than 2, less than 2.
At most 2, right? So if both these conditions are satisfied and I find that there are 2 or more than 2 such words in this sentence, so only then C will be greater than equal to 2, right? So once this is true, then I will come inside this if statement and increment A by 1, this A variable. Now I have some statement here and I have some statement outside of this inner if, and then I have move X to table 2. So this statement 1 and statement 2 I need to find out. So what is this procedure? Count vowels. This count vowels is a procedure, right? X is what? If I write something in parentheses, that is what? Count vowels is your procedure name. What is X?
Parameter.
Parameter. That is the current card you have picked is the parameter. So as soon as you come to this part of the code, it will go to the function definition or procedure definition. So what does this procedure do? First, the job of this procedure is to count the number of vowels in a particular word or card. Okay, so whatever card you pass, what it will do with that card. First, I have a variable I which is initialized to 1, B which is initialized to 0. So while I is less than equal to y dot letter count, that is the word you have passed. Okay, let's say I pass my name. So my name is a noun, correct? So what is the letter count in my name? 8.
It's later.
So y dot letter count will be what? 8. I is starting with what? 1. Is 1 less than equal to 8?
Yes.
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 So I will enter the while loop. Check the if condition. If ith letter of y dot word is a vowel. So is the first letter of my name a vowel?
No, ma'am.
No. So this if statement will not be executed. I'll go to this statement 4, whatever this statement 4 should be. I don't know what it is. So what do you think this statement 4 should be if I want to go to the next letter in my name?
Maybe constant.
Ith letter of Y word is a consonant.
Can I do this? If I want to check the next letter of my name, I have to increment I, right? I has to be 2 so that I can find the second letter. So
And
that leaves us.
we have to check letter one after another in the
Yes,
word.
yes. See, the while loop is given what? I less than equal to letter count. So as long as I is less than equal to letter count, we will keep on iterating. So this I has to increment for that, right? One iteration. First iteration I is 1, second iteration I is 2, third iteration I is 3. Like this, it will continue. For my name, it will continue till I has become 8. As soon as I becomes 9, this while loop condition becomes false. So we will get out of it and return statement. Have one of these statements, increment statements, right? So this increment statement will either be in statement 3 place or statement 4 place. I don't know where it should be, but I know that this statement should be there, right? So let's say I have this statement somewhere. So next iteration i's value will be what? Value of I will be, if I incremented it,
It
2.
will be 2.
So 2 is less than equal to A. Now what is the second letter? A. So is the ith letter a vowel?
Yes.
Second letter? Yes. So you increment B. Okay. So B is basically capturing what? The number of vowels? Yes. So statement 3 and statement 4, we still don't know what these are, but we definitely know that one of these statements has to be the increment statement. So basically the job of this count vowels procedure is to count the number of vowels in any noun. Okay. Or any card. Any card we can do it. Why I'm saying noun is because in our particular problem, we need only those cards which are noun. Only for them we will check the vowel count. Okay. So now let's check the options. So we need all 4 statements. Statements 1, 2, 3, and 4. What should they be? So this type of questions, it is required to always check the options. Okay, that will make solving it easier. So see, if I do this, statement 1, first option has given statement 1 not necessary. So it is saying that I don't need anything here. Fine, I don't put anything here. Let's say the statement 1 is not there. Statement 2 is given C equals to 0. So they're saying instead of statement 2, it should be C equals to 0 here. Okay. Statement 3 again not necessary. So it is saying nothing should be here. And statement 4 should be I equals to I plus 1 that I have written. So if I follow this, now let's check that is this working? Is this procedure working or not? Is it solving our problem?
Ma'am, A is a count of sentence.
A is doing what? See, A is being incremented here. So A will be counting those sentences which are satisfying all the
Ending with full
conditions.
stop.
Okay, ending with full stop means that we have reached the end of a sentence. So A is counting the number of those sentences which have satisfied the condition, where C is greater than equal to 2. C is getting incremented here. where both these conditions are satisfied. That is, the word is a noun and vowel count is greater than equal, less than equal to 2 it is given. Wait 1 second. At most 2 vowels. Yeah, less than equal to 2. Okay. So C greater than 2 signifies what? That we have at least 2 such words which are noun and whose letter count, vowel count is at most 2. Right.
Yes. Right.
So if I follow this, whatever is given in the first option. So by that logic, why have I given C equals to 0 here? Why is C equal to 0 given here in place of statement 2? Because when
Variable
one,
for
yeah, go on.
we cannot assign same variable. So
So
in
we
the
have
above,
to reset that
yeah,
variable, right, for the next
yeah,
sentence.
yeah.
So that I
So
can
this is
again
wrong.
count that how many nouns are there which have the particular vowel count that we need. So that's why C is being reinitialized. So definitely C equals to 0 should be here in place of statement 2. Okay. So if I put this, okay, statement 1 is not needed. That means inside this if statement, only A equals to A plus 1 is enough. In case of statement 2, I have placed C equals to 0. Statement 3 is again not needed. In place of statement 4, I have put I equals to I plus 1. So what would happen if I place this I equals to I plus 1 in place of statement 3? What would happen then? Let's say here I incremented B. That example. Okay, first I is 1. So I saw that it is not a vowel. So I did not execute. I'll go for the next iteration where I is 2. I found a vowel. B is incremented. Now I is incremented here. I equals to I plus 1. Okay. After that, let's say there is nothing there in statement 4. So will that create a change? Will this result in any change or is it giving the exact same thing? Whether I is inside or outside the if. This increment statement basically can be anywhere. Whether in statement 3 or statement 4, it does not matter. Okay. Even if you increment it inside the if, it will still be correct. If you increment it outside the if, it will still be correct. Because we just need to increment it. And it will only be incremented one time if the condition is satisfied. Right. I anyways have to check the next letter. Whatever is my current letter, current I value, I have to check the next I value until and unless I has exceeded my letter count, that is 8. That is the while condition. So I needs to be incremented, right? So what would happen? So why didn't anyone correct me when I said that I can place this in place of statement 3? Nobody corrected me. What is the wrong thing here? What if my letter that I am examining is a consonant? In that case, if I place this I equals to I plus 1 in place of statement 3, won't it be wrong? Because it will not enter this if condition at all. For the first letter check, when I was 1, so is M a vowel? No. In that case, if here I had I equals to I plus 1, then will I get incremented ever?
No.
So that's why this must be in the place of statement 4. So that thing you should have caught. Okay, so pay attention. This is why I do this every time. No one ever picks up on it. This is not the same thing. It is very important where you place these increment statements. Okay. So when a condition is getting satisfied, only then a certain set of statements will be executed. Right? But we cannot have this boundary here because we have to check the letter of like every single letter in this word, regardless of whether the letter is a vowel or a consonant. That means I will be incremented regardless of whether my current ith letter is a vowel or a consonant. So when will that happen? When I place it in place of statement 4, which is outside of this if condition. So it needs to be here, not in place of statement 3.
Yes.
Correct? Understood? Difference understood?
Yes, ma'am.
Okay. So these things are very like little mistakes that you can make. Okay. So there might be an option here. So in place of statement 4, if I put that statement 4 not necessary, statement 3 I equals to I plus 1. If you put this as your answer, this becomes wrong because of this little mistake. Okay. So just be attentive of that. So here option A is correct. So if I put these, wherever these statements are given, this will give me the correct output. Okay, now let's evaluate it once with all the correct statements. Let me just erase all this. So statement 1 not necessary, statement 3 not necessary. Statement 2 should be here. I should have c equals to 0. This is not required. This is also not required. Here I should have I equals to I plus 1. So let's say I have a sentence which is, I'm just writing the part of speeches. Okay, let's say I have in this sentence, the first word is a noun with vowel count 1. Okay, next word is a verb. So the second word, whatever is the vowel count is not necessary because only I will check for nouns. Right? In the AND condition, if one of the condition fails, that means the entire thing fails. So if the part of speech is verb, that means I don't have to check for the vowel count. Let's say the third word in my sentence is also a noun. Third word, vowel count is 2. And the last word is, let's say, some adjective. Okay. Again, so these are the 4 words in my sentence, let's say. So if I follow this pattern, whatever is given in option 1, then what happens? First A is 0, C is 0. So table 1 currently has all the rows in the words data set. Right? So read the first card. So first card has a word which is a noun. Right? My first word is a noun. So check the if condition. If x dot part of speech is equal to noun, will this part be true?
Yes.
And vowel count x is less than equal to 2. Vowel count is 1. So is this true?
Vowel count is 2. NOU. OU.
Yeah, but for the first word I have written vowel count is 1 in my data set. So is the
Okay.
condition satisfying? 1 less than equal to 2?
ma'am.
Satisfied?
Yes, ma'am.
Both conditions satisfied. That means AND is working here. So both conditions satisfied. So I will enter the if block. Increment C by 1. So C was initially 0. So now C becomes what? 1. Next if line 7. If x dot word ends with a full stop, this first word, this noun, is it ending with a full stop?
No.
No.
No, right? It is the first word of my sentence. So no. So no need to do any of this. Again, go for the next iteration of this while loop. What is the next word? This verb.
Verb.
So check the first if condition. If x dot part of speech noun, is it
No.
matching? No.
No.
So will I check any further?
No.
So next if condition you have to check. Is the word ending with a full stop? Is this verb ending with a full stop?
No.
No. Go to the next condition. Move this to the table 2, go to the next condition. Next iteration. Next word I picked. Again check. Is the part of speech noun?
Yes.
Yes.
Vowel count is less than equal to 2?
Yes.
Yes. Both conditions satisfied. So C is again incremented. Now C becomes what?
2.
2.
2. Now come to the next if condition. Is it ending with a full stop?
Yes.
This noun, this third word is
No.
ending with a full stop.
No, ma'am.
No.
So none of this
No.
is executed. Move it to table 2. Go for next iteration. Now I pick the fourth word. Is it a noun? No.
No.
No, ma'am.
I won't check any further. I'll go to the next if. Is it ending with full stop?
Yes.
Yes. There is a full stop. At this point, go to the inner if. Is C greater than equal to 2?
No.
C is 2.
2.
So 2 is greater than equal to 2. Condition satisfied. So increment A by 1. A was initially 0. Now A becomes what? 1. Right? Come out of the outer if. Again reset C to 0. Because we have reached the end of a sentence. Now I will again start checking for the next sentence. So A is storing what? Number of sentences which contain at least two nouns that have at most two vowels. Is this clear? Entire code?
It could be more than two nouns.
Yeah,
At
it should
least
have at
minimum.
least two.
Yeah.
That's why it is
Okay.
given C should be greater than equal to 2. It should be at least 2 or more than 2.
Okay, ma'am.
Okay. Clear this? Anyone? Any question? Okay, this is a very good question. This type of question can be there in your quiz 1 qualifier. Okay, so just check with the options. If you are confused, just put the values in the options like I did. For whichever option it works, you put that as your answer. So this can be a little time consuming, but once you practice this question, just by looking at the answer, you can tell. Okay, like in this one, here, this option you can eliminate how? Statement 3, I equals to I plus 1. If I put I equals to I plus 1 inside the if condition, I told you this will be wrong. Because for the consonants, I won't be able to increase I. Right? So you can eliminate options like this. Just practice. Okay. Third question. Following pseudocode is executed using library dataset. So this has the book and author information. At the end of execution, N captures the name of a book which has the maximum number of pages. Okay. N captures name of a book which has maximum number of pages and is written in a language other than English. Okay. So two conditions are there. The book must be having maximum number of pages among all the books, and it should be written in a language other than English. And A
It should
captures
not
what?
be. Yeah.
Yeah, it should not be written in English, basically.
Yeah.
And A captures the number of pages, that is that maximum number of pages, what it is. A will capture that. So N will capture the name, A will capture the number of pages. Okay. Now it is said if the rows of the tables are shuffled in any random order, then choose the correct option. Okay. So let's say the rows are in any random order in your library data set. So let's see the code. First, A is initialized to 0, N is initialized to none. Because N is going to store a string type of value, right? The name of the book. So it is initialized to none. While table 1 has more rows. So the first row I pick, random sum row, X. So it has the information of a book. So you first check, is the language of that book English? If it is not, then it is satisfying the condition because X dot language not equal to English. And X dot pages greater than A. A is initially 0, right?
Okay. So it should be more than 0.
Yeah. So let's take a little small data set. Let's say I have 4 books. First book is, I'll take some book ABC. Okay. Let's say it has 20 pages. I'll take some book DEF. It has, let's say, 30. And some book XYZ, which has, let's say, 60 pages. Okay. ABC is written in English. Am I audible?
Yes, ma'am.
Okay,
Yes,
just
ma'am.
let
Yes,
me know.
ma'am.
Okay, if there is a disturbance in my connection, just let me know since I'm not at home. So just text like write on the chat box or just turn on your mic and tell me. Okay. So ABC is written in English. This is not in English. This is again in English. And this one is also English. Okay, now let's check. This is the first book in my data set. So ABC I picked. So while table 1 has more rows, read the first row X. So I picked this ABC row. Is the language not English? Well, let's change this to not English. Last one. So the language is English here. So this condition is violated.
Yes.
Yes.
No need to check the rest of the conditions. Just move it to table 2. Pick the next one. DEF. Is the language not English?
Yes.
Not English.
Yes, ma'am.
Number of
Condition
pages.
satisfied.
Yeah. But two conditions. Both have to satisfy because and is there. So number of pages. Is it greater than A? A is initially 0. It has 30
Yeah,
pages.
it
So
is.
30 greater than 0. Both conditions satisfied. Now A will be updated to the number of pages
30.
here. So A
30.
becomes 30. N becomes the name of the book, that is DEF.
Yeah.
Okay, done. Now move it to table 2. Pick the next one, EFG. For that, again check is the okay. Let me put one more row here so that we can have a more comprehensive understanding. So some PQR book which has 100 pages. Let's okay.
So
So for this one, now next EFG I picked.
this
Again
will not
language,
execute.
English language. So again violated, not execute. Right. Put it to the table 2. Go for next iteration XYZ. Language not English. Fine. A is currently 30. That has been updated during DEF. So what is the page count here? 60. Is 60 greater than 30? Yes. So
Yes,
both
ma'am.
conditions satisfied. So again A will be updated. New updated value of A is
60.
60. New updated value of N is XYZ.
XYZ.
Okay. Now move it again to table 2. Now go for the next one. PQR. Is language English? No. So satisfied. Number of pages is 100. Current pages is 60. 100 greater than 60. Both conditions satisfied.
Yes, ma'am.
A will be again updated to 100. N will be updated to PQR. Okay. So now you understand how the code works, right? So if the rows of the table are shuffled in any random order, now if the rows are shuffled in any order, so now check which of these are correct. Okay. That means the library data set, whatever data, whatever rows it had, they are shuffled. Okay, in some order. So will there be a change in N irrespective of the order of rows?
Yes.
So first option is saying that there will be no change in the name of the book irrespective of the order of rows. Is this correct?
No, ma'am.
No.
No matter in which order I have the rows, N will be the same. Now I might have two books which have the maximum page count. There is both books have 100 pages, right? But in some random ordering, the second book comes last. So N will be executed and the last name will be stored, right? For example, let's take one more book which is not in English. Let's say some book, MNO. Okay. It also has 100 pages. So in this particular ordering, when I come to the next one, so this will again, will this be changed? So currently A is 100. So when I come to MNO, okay, language is not English, fine, but is 100 greater than 100?
No, ma'am.
So will N be changed?
No, ma'am.
No, ma'am.
Not be changed. But in some other ordering, let's say where MNO comes before PQR comes, in that case, N will be MNO. And for PQR, if it comes later than MNO, in that case, PQR will not be stored in N. Only the first one, which comes first, right, that will be stored. The maximum pages book, which comes first. Two books might have the maximum page number, same maximum page number. But it depends on the ordering, which one of their names will be stored, right? That means first option is wrong. N will be changed irrespective of the order of rows, right? Depending on in which order your rows are there, N will change.
Yes, ma'am.
Is this understood? Should I explain it again? Anyone?
No, ma'am. Understood.
Okay. Second option is saying there might be a change in N based on the number of rows. So yeah, we just saw that. N will change based on the order of rows. So B is correct. It is saying C is saying there will be no change in A irrespective of the order of rows. Is this correct? A is storing the maximum number of pages.
Correct, ma'am.
So maximum number of pages will never change, right? No matter which ordering it comes in. Whether PQR comes first or MNO comes first, both of them have 100 maximum number of pages. So that 100 value is fixed, right? Irrespective of the ordering, that will be the maximum value. So A will not change with the order of rows. A will be fixed no matter what the order is. So C is correct. There might be a change in A based on the order of rows. No. So B and C are correct. Any doubt in this question?
No, ma'am.
No, ma'am.
So let's do 5 questions. There are 10 questions here. So since you don't have anything much left in this week, so other 2 sessions you ask the instructors to solve the rest of the practice and activity questions you can do. Okay, but I will say that exam point of view, practice and graded assignments are more important than activity questions. Okay, these are the types of questions that you will get. So yeah, let's do question 4. The given pseudocode is executed using shopping bills dataset. So this is good. See, we are checking all the data sets. We did library, words, scores, now shopping bills. So frac is a variable which stores the ratio of the number of customers who purchased. Okay, so this question has come many times in PYQ. Okay, so this is important question. Frac is a variable which stores ratio of number of customers who purchased both bread and milk to the number of customers who purchased just milk. Okay, that means they may or may not uh, the first group of people who are in the numerator, they must have purchased milk. Okay. And for the second group of customers who are going to be in the denominator of the fraction, we are just checking whether they have purchased milk or not. Okay. We don't care whether they have purchased bread. So for everyone who has purchased milk, they will be in the denominator. In the numerator, there will be people who have purchased both bread and milk. So which is the smaller set, the numerator or the denominator? See, frac is a variable. It stores ratio of number of customers. That means it's in a fraction, right? So I can write number of people who have purchased both bread and milk by number of people who have purchased milk. I don't know whether they have purchased bread or not, but I definitely know they have purchased milk. So which one is the bigger set, this one or this one?
Later is bigger, ma'am.
This one is bigger. Or one more thing can be that they both are same. Okay, that means everyone who has purchased milk has also purchased bread. In that case, it will be 1. The ratio will become 1. But let's say that's not the case. So there are definitely people who have brought milk but not bought bread, right? So that makes the second set a bigger set because everyone in this first set is also included in the second set. Everyone who has purchased bread and milk has definitely purchased milk, so they are included in the second set. Everyone who has purchased milk but not bread, they are also in the second set, right? The second set denominator is the bigger set. Now choose the correct code fragment. Again, you have to complete the pseudocode. So let's solve the code first. M count and B count, 2 variables are there which are initialized to 0. While file 1 has more cards, read the top card, shopping bills dataset. Okay, so you read first card, something is here, then you move it to pile 2. Okay, now this entire while loop execution will finish. Then we will come to statement 9. Okay, after this while loop has completed execution for all the cards in the pile, then you'll come to line 9, where frac will be what? B count by M count. I don't know what B count and M count are storing because they must have been updated in this part of the code which is missing. Okay, so we have to find that out. Next, we have this procedure called isItem. I don't know where this procedure is called, but it must have been called somewhere in this missing code. So isItem procedure does what? It takes Y and A as parameters. I don't know what is Y, what is A. Okay. So Y is apparently some card. You can see while card Y has more items. So Y is some card. A is what? I don't know. So in this case, you don't know a lot of things. Then what will you do? Go to the options. So let's take the first option. This is the missing part of code. So missing part of code will be placed here. That means inside the while loop. So you pick one card from your shopping bills data set X. That card is X. Now you are inside the while loop. You are having this if statement. If is item X comma milk. So is item X comma milk. So now put this parameter into the function definition. That means this is the card and A is what? Milk. Right. This is the parameter. So for this,
Right.
let's see what it is doing. C is first initialized to false. While card Y has more items. That means we are iterating through all the items in card Y. So you read one item, first item Z, check if that item is equal to A. That means you are checking whether that item is milk. Then C will be set to true. So for a card X, C will be set to true when that person has purchased milk. That is, milk is in their item list. Yes or no?
Yes.
Right. C will be set to true if this matches. That is, the item is milk. That is, milk is present in their item list. Then C will be true. Otherwise, C will remain false. So if I find such a card where milk has not been purchased, in that case, C will remain false. Okay. Now, based on whatever C's value is, that value will be returned at the end. So if a person has purchased milk, that means true value will be returned. So here the is item procedure was called. So if it returns true, that is if true, that is the person has purchased milk, the person whose card this is X, he has purchased milk, then M count will be incremented. Okay. So M count is basically storing what? That means people who have purchased milk, number of people who have purchased milk. Yes or no?
Yes, ma'am.
Up to this, is it? Does anyone have any doubts? You tell me. I'll explain again. Okay. Yeah.
I mean, this item, they have told the procedure, what would be the in the blank mm, place.
No, see, in this option, first we see that there is one if statement, which is calling the procedure is item with these parameters, X and milk. X is the card you have picked from shopping bills dataset, and this second parameter is milk. So now we check what is item procedure doing. So item procedure is first initializing C variable to false. Then it is checking all the items that this X card has purchased. This person with the X card, what items he has purchased. If any of those items is milk, then it will set C to true. Otherwise, C will remain false. Now, whatever is the C value at the end of execution of the while loop, that is once we are gone through all the elements, once we have gone through all the items in his list, that C value will be returned. So if he has purchased milk, true will be returned. If he hasn't purchased milk, false will be returned.
Right.
So if true is returned, then if true, that means I can enter the if block and increment M count. So every time M count will be incremented when this is item returns true for milk. That means
Okay.
M count is storing what? Number of people who have purchased milk.
Yes.
Okay. Similarly for bread also we are doing this in the next if is item X comma bread. So now again you are doing the same procedure. Instead of milk you are now checking for bread. That okay, has a person purchased bread? If yes, then true will be returned, B count will be incremented. So M count is storing what? Number of people who have purchased milk. B count is storing number of people who have purchased bread. So if I go with option A, okay, then at the end of this while loop, when I come to line 9, then B count by M count is giving what? Is it giving what we need? We need this. Number of people who have purchased both bread and milk by number of people who have purchased milk. So M count is fine. It has the number of people who have purchased milk. But is B count giving number of people who have purchased both bread and milk?
No.
B count is getting incremented and checking only for bread, not checking for milk. Right? So all the people who have only purchased bread, they are also coming in this B count, even if they haven't purchased milk. So that means this is not the correct option. So next option is checking that is item bread. First it is checking for bread. If you have purchased bread, B count is incremented. Next, inside this, so this is a nested if. Okay, so first it will count for B count. Okay, so if you have purchased bread, only then this is item will return true and B count will be incremented. Then I will come to this nested if and check if that person has also purchased milk or not. For bread, I have already checked. Now I'm checking whether that same person has purchased milk. Then M count will be incremented. Okay, so if I follow this, then what happens? Then B count is storing what?
Only
Is this
bread.
still is this still correct? It is not.
No.
B count is still storing only the count of people who have purchased bread. And M count is storing what in this case? People who have purchased both bread and milk.
So here is a or condition, na ma'am?
No. And condition. B count should have both. People who have purchased both bread and milk. And M count should be people who have purchased milk. I don't care whether they have purchased bread or not.
No, no, but in option B, there is or condition. Na?
Or condition means this is and means if the outer if is satisfied, only then I will enter the inner if. That is, if a person has purchased bread, then only I will check whether they have purchased milk or not, because it is nested if. Okay. So here B count is still storing the people who have purchased bread. Those people might not have purchased milk. But M count is storing the people who have purchased both bread and milk. But does that solve our problem? In our problem, B count should be the people who have purchased both bread and milk, right? So this option is also wrong. Let's check option C. If is item x comma milk and is item x comma bread. This we are checking both at the same time. If both are satisfied, that means the people have the person whose card we have X, he has purchased both milk and bread. Then we are incrementing M count and B count together. Is this correct?
Yes, ma'am.
Everyone is agreeing that this is correct.
No,
Ma'am,
ma'am.
because this is not separately counting the milk purchase
Exactly.
customers.
So this will count for people who have purchased both bread and milk. But where are the people who have purchased milk but not bread? That should also come under M count. Right. In question that is given that frac should be number of people who have purchased both bread and milk by number of people who have purchased milk. So this is also wrong. So this option must be correct. So how this is correct? See, first we are checking if the person has purchased milk. If this is true, increment M count. Then you check whether that same person has purchased bread. Then you increment B count. So now B count is storing what? People who have purchased both bread and milk. Because the if condition, inner if, will only be checked when the outer if is satisfied. So if a person has purchased milk, then only we are checking for bread. That means B count is storing the number of people who have purchased both bread and milk. And M count is storing what? People who have purchased milk. So let's say if some card X, the person has purchased milk but no bread. In that case, which of the variables will be incremented? M count or B count?
M count.
M count.
And if someone has purchased both,
B
then both
count.
variables will be incremented. M count also, B count also. Right? For milk, we will increment M count. Then we check for bread. If that is also present, then increment B count. So B count is storing what now? People who have purchased both items, bread and milk. And M count is storing people who have purchased milk. Whether they have purchased bread or not is not our concern. So is this correct?
Yes, ma'am.
So option D will be correct for this. Understood? Any question from this one? Any doubt?
Ma'am, can we go to the option C?
Yeah.
Can we write this code in this way with the using
See what
with
happens
and
here. Yeah, if I write
and
with and, writing this is difficult with and, because if you check both conditions at the same time, then how will you know? Then you can do this for B count. Okay. You check if you want to write it using this. Then one way of writing this code is first I have to write one if is item uh, x comma milk. Okay. Then inside this if I increment M count. Okay.
okay.
After this, if I have this if condition, that again I'm checking that if this person has purchased bread and milk, both, then you can remove this M count and just keep this B count. This will also give the correct answer. But there is no
Yes,
point in
ma'am.
checking the same procedure twice, right, for milk. So that's why
Mhm.
using a nested if is better in this case.
Okay, ma'am. But this is more easier.
Yeah, no,
This is much
nested
easier,
one is
yeah.
easier. Yeah. Okay. Any doubt from this question 4?
Manideepa, I have one doubt. This
Yeah.
is basics. The while and if. So, which situation you need to use while and if I know that, but while I'm just a little bit confused. So
Just
it's
explain it again. What your confusion is. I didn't get it.
the while you when we need to use and if when we need to use.
While is when we want to iterate through a pile of something. That is, we want to check one card after another in this entire pile. Okay.
Okay.
That is
Okay.
for while. If is when you want to check a particular condition. So when
Okay.
I have picked the card, now for that card, I want to check a condition. Like for this X card, I want to check if the person has purchased milk. So this condition will be in the if statement. If is a conditional statement, while is an iterative statement.
So while means it will make
While is a loop.
loop,
Yeah, while is
right?
a loop. Correct. And if is a conditional statement.
Okay, understood. Okay, okay,
Yeah.
thank you.
Okay, any more doubt from question 4? Anyone? Should we do the next one?
Yes, ma'am.
Okay, so I'll just keep it up to, okay, 5 and 6 are together. So we'll solve these two, then rest of these you can solve in the next 2 sessions because nothing more is left. Okay. So the following pseudocode is executed using scores dataset. Again, scores dataset, that's students' information. So two students from a study pair form a study pair if their difference in mathematics marks are at most 10. So here the problem is what we want to form study pairs, that is a pair of students who can study together. What is the condition for that? That their mathematics marks difference should be at most 10. So it should not be more than 10. If the difference in their maths marks is at most 10, then they can be paired together. Okay, this is the problem. So assume that file 1 is always restored back after calling this procedure, whatever the studied pair does. So we'll see that. So let's check the code. This is a bit of a big code. So first there is a variable called count1. Count1 is calling this study pair procedure with pile1 as the argument. So pile1 means the entire scores dataset. So as this calls it, the control will shift to line 17. So what does this procedure do? It has a variable a, okay, which is set to 0, initialized to 0. Then you start a while loop. So now I'll iterate through all the cards in pile 1, in scores dataset basically. So you pick the first card, read it, move it to pile 2. Then again there is a nested while. So these are nested iteration. That means what do we know? If there is a nested iteration means there might be some comparison, right? So this is where we used binning concept. So if there is a nested iteration, then we know some comparison is there. So first I have picked card X. Now card X has been moved to pile 2. So pile 1 does not have card X anymore. Let's say pile 1 initially had 30 cards. So after I take card X out and place it in pile 2, now pile 1 has how many cards?
29.
29 cards. So these 29 cards will be now iterated in this inner while loop. Remember, this is for first iteration of outer while. So while pile 1 has more cards. So now 29 cards are there. So for each card, what is happening? You read the top card, name it Y. Once you have read it, move it to pile 3. Okay. Now you check if negative 10 is less than equal to the difference between X math minus Y math. So basically the difference between X math minus Y math. First, let's take a some pair of values. Let's say X dot math is 60, Y dot math is 7, let's say 69, 68. Okay.
Ma'am,
So
this is
X,
written -10, so is this the way to write the difference
yeah,
of 10?
you can see this code is written in this way to confuse you. Okay. There is no need to write in this way. You can just take X minus Y absolute value and check whether that is less than equal to 10. Okay. But since we don't know the concept of absolute values yet, that's why we have taken both negative and positive.
So here is range between.
Yeah. So if you, let's say, if X says marks is less than Y is marks, then the difference will give us something in negative, right?
Right.
X minus Y will give something in negative. That's why we have taken the negative one also. But once you learn about absolute values, that is mod values, where we don't consider the sign, then there is no need to write this positive negative. We can just check for 10. Okay.
Okay, ma'am.
So right now we don't have it. So let's do it this way. So X has scored 60, Y has scored 68. So X minus Y will be what? Minus 8. Correct? So now check the condition here. Is
It's
minus
not
10 less? Is minus 10 less than equal to minus 8? Yes. Minus 10 is lesser than minus 8. Is the other condition satisfying? Is plus 10 greater than equal to minus 8? Yes. 10 is greater than minus 8, right?
Yes, ma'am.
Yes.
So
Yes,
both of
ma'am.
them are satisfied.
Minus 8, how it's calculated?
X has got 60 in math, y has got 68 in math. Now the
Okay.
condition is checking x minus y. So 60 minus
Okay.
68 is minus 8. Now
Okay.
check with both conditions on both sides. So minus 10 is less than equal to minus 8, correct? Again, minus 8 is less than equal to 10, correct?
Yes, correct.
Both
Yes.
are correct. So you can
Yes,
enter the if block and increment a. Okay. Once this is done, now go for the next iteration. So tell me now, initially this had 29 cards. Once the first iteration is done, now it has how many cards? 28 cards, because this y card was moved to pile 3, right? So again you do for the next 28 cards, pick up one card. Let's say now, so x remains same, x is 60. Now the next y, x dot math. Let's say this person has scored uh, 48 in math. In that case, x minus y becomes what? 12, right? So now in place of minus 8, you put 12. So is minus 10 less than equal to 12? Yes. But is 12 less than equal to 10?
Mm,
12 less than
No.
equal to
No.
10. This condition is false. So if one of the conditions fails, that means I cannot enter the if block. So a will not be incremented. So when will a be incremented? When the difference between x and y is within 10, right? 10 or less than 10. Is that clear? X and y maths marks, the difference between them should be 10 or less than 10. Only then a will be incremented. Why this minus sign is there? Because it might happen that x has scored lesser marks than y, like this example. But again, it can happen that x has scored greater marks than y. In that case, this example, this y and this y. So we have to check for both signs. That's why we have negative as well as positive. Okay. So a will only be incremented when this difference, basically, if you take the absolute value between x minus y, like if I do x minus y and remove the signs. Okay. So it can be, the difference can be anything from 0 to 10. Okay. Then we will increment a. But as soon as the difference exceeds 10, then we cannot increment a. Because our problem says that they can be a study pair if their difference in maths marks is at most 10. That means 0 to 10. Understood? Is this inner study pair procedure understood?
Understood.
See,
Understood.
a means what? So what is
Understood, ma'am.
a storing? Yeah, just tell me what is a storing. What is a? A is
Take
the
the
number of
difference.
such pairs.
A means
Yes. Yeah.
greater than equal to minus 10 and lesser than equal to 10.
So for those people who satisfy this if condition, for them a is being incremented. That means for such an xy pair which satisfies this negative 10, positive 10, this condition in the if, only for them the a will be incremented. So a is keeping track of how many number of such pairs are there, how many such xy pairs are there, right? Whose difference in marks is 10 or less than 10. So a is calculating that. So study pair procedure is okay, right? Now once this inner while loop has finished executing, right, we move all the cards back from pile 3 to pile 1. So tell me, I picked first one card x from pile 1, and then I came into this inner while loop and executed this inner while 29 times. So at the end of execution of inner while, all the cards were shifted to pile 3, right? Because every time we moved y to pile 3. So at the end of the execution of inner while, we will have to move all these back to pile 1 for the next iteration of outer while loop, right? Just like
Yes,
we did
ma'am.
in the beginning. So this will happen. So study pair procedure is doing this. It is just A is storing how many such pairs are there who can form a study pair. Okay. So I think the first question is based on this only, or no, we have to do this also, I think. Yeah. Okay. So how many such pairs are there? That will be returned by the study pair procedure, C return A. So this A value will be stored where? In count 1, which initially called the procedure. So count 1 contains number of valid
Study
study
pairs.
pairs. Good. Next, go to line 2. While pile 1 has more cards. So at the end, what it is saying that assume that pile P1 is always restored back after calling study pair pile P1. Right. So we call this procedure, but we are assuming that now pile 1 has been restored to its initial form, that is 30 cards are again present in pile 1. So now in line 2, we are again going to iterate through this pile, course data set. So you read the top card. So for that card, you check, is the city town Chennai? If it is Chennai, then move X to pile Chennai. That means now we have created 3 different files for 3 different cities. One for Chennai, one for Bangalore, one for Vellore. Okay. So if the person's card who we have picked is from Chennai, then you move their card to this Chennai pile. If they're from Bangalore, then move it to Bangalore pile. If they're from Vellore, move it to Vellore pile. So in any case, it will be either one of these 3, right? Or it won't be this at all. So if some person is from Kolkata, they won't be in any of these piles. So what is this doing basically? This is a binning, right? Based on city.
Yes, ma'am.
So based on city, we are dividing the cards. Okay, so we are creating 3 piles, one for Chennai, one for Bangalore, one for Vellore. They will have people from these particular cities. After this entire while loop execution is done, then we come to line 14, count 2. So count 2 is now doing what? Study pair, pile Chennai. So what, just tell me what will this part return? Study pair, pile Chennai. How many study pairs can be formed in people who are from Chennai? Right?
Right, ma'am.
Following this same procedure that we saw. Then again, plus study pair from Bangalore, study pair from Vellore. So we are adding all the study pairs that can possibly form from these 3 cities, right? Separately. That is one group of study pairs who are from Chennai, one group of study pairs who are from Bangalore, one group of study pairs who are from Vellore. We are adding them together. Next, line 15, count 3 is count 1 minus count 2. So count 1 is irrespective of cities, it is finding valid study pairs. And count 2 is storing the sum of study pairs from these 3 cities. Count 3 is storing the difference between the 2. Okay. So now let's see what the question is asking. What will count 1 represent at the end of execution? We already saw number of study pairs. Right.
Yes,
Is this option correct? Anyone has a
Yes, ma'am.
different option?
ma'am.
Okay.
Ma'am, can you explain 15 line?
This one. Yeah, count 3. See, once count 1 and count 2 are done. So count 1 is storing what number of valid study pairs, irrespective of cities. Count 2 is storing the summation of study pairs from Chennai, Bangalore, and Vellore separately. Count 3 is storing the difference between count 1 and count 2. Okay, just doing a normal subtraction, nothing else.
Okay.
So what is count 3 basically storing? All the study pairs except those from Chennai, Bangalore, and Vellore.
Yes, got it.
Okay. So what is question 6 asking? What will count 3 represent? So what is count 3 representing? Number of study pairs where both the students in each pair are not from the same city among Chennai, Bangalore, and Vellore, because we have already taken these out. So maybe one of the student is from Chennai, one of the student is from Bangalore. They can form a pair, but both of them cannot be from Chennai or both of them cannot be from Bangalore. Understood? Should I explain this?
So, ma'am, initially you form the pairs, study pairs, then Chennai, Bengaluru, Vellore students are
Eliminated.
removed. Yeah, eliminated.
But this
And the rest of
Chennai
the
pile,
pairs are, yeah.
yeah,
The
but
count
this
3
Chennai
contains the
pile
rest
is
of the
containing
pairs.
what? Chennai pile is only having study pairs where both students are from Chennai, right? And Bangalore is
Yes,
having study pairs where both students are from Bangalore. Similarly for Vellore. So once I take all these out from the initial number of valid study pairs, what is left? Number of study pairs where both the students in each pair are not from the same city, where the city is Chennai, Bangalore, or Vellore.
yes, ma'am.
So there may be a pair of students who are both from Kolkata. That is valid. Or there may be a pair of students who is one from Chennai, one from Bangalore. That is also valid. But they should not be both from Chennai, both from Bangalore, or both from Vellore.
Yes,
Okay.
ma'am.
So option B is correct. Okay. Any doubt from this code? This entire code for 5 and 6? Okay.
Madam, that's the procedure steady pair
Hmm.
pile one. So first, initially, it is the second loop. It will calculate and store in uh, uh, how the steady pair is created. Actually, how it will come actually. Steady
So
pair Chennai.
what is the for Chennai when you pass for pile Chennai, right? See, first you're
Okay.
creating the pile. That is, you're checking through the entire scores data set, and every time you find a student from Chennai, you move their card to pile Chennai. You
Okay.
find one
Okay.
from Bangalore, you move it to Bangalore. So like this, you're creating 3 piles for 3 different cities. After that,
Okay.
in count 2, you're following the study pair procedure 3 times. One for Chennai pile, one for Bangalore pile, one for Vellore pile. So what it will do in study pair pile Chennai, this first one, it will calculate how many such pairs of students are there who are both from Chennai and they can form a study pair.
That I understood, ma'am. Then below
Yeah. Which
here,
line?
what is that actually? So how and the
Which line? You're not audible. Do you need me to explain this procedure once more? Study pair. Can others hear him?
17.
Okay. From line 17.
Yeah. So
So how study pairs are being
yeah,
calculated?
17 to 29. Okay, 17 to 26. So what happening actually? The steps
See,
actually.
what is happening? Let's see, if I take this pile Chennai, okay. So these are all people from Chennai, right?
Yes.
So now you initialize A to 0. Okay. Now you check whether Chennai pile has more cards. So I will iterate through all the cards in Chennai pile. I'll read the
Mm.
first card. Okay. Then move that card X to pile 2. Now
Okay.
I have
So
an
in
inner
this
iteration.
group, first we are grouping the Chennai, Bangalore, Vellore. Then second procedure from this between the range, how many pairs are there that we are
Yes,
calculating,
yes.
right?
How many people are there who have scored maths marks which are in the range of 10?
Okay,
Difference is in the range of 10.
but in the system, how the flow, it will complete first group, then it will go second group, right?
Yeah, first it will run this procedure for Chennai, then it will run the same procedure for Bangalore, then for Vellore.
Vellore.
Okay.
Then below structure will below procedure will fall again. It will run,
Yeah,
right?
then it will do the summation for these three since they're added together.
No,
Okay.
madam. I'm talking about 17 to the 26th. I'm just asking from
This
row
is
one
just a
to
procedure. This is just a
yeah.
procedure definition. Okay. This will run when the procedure is called. Like in line 14, the procedure study pair is called. So here it will run. Here it will run again. Again it will run here. Wherever it is called. So in line
Mm,
14, this same procedure will run 3 times for 3 different files.
okay.
Okay, and it will return the value of how many pairs are there from that particular city.
My question, okay, maybe I don't know how to explain. Okay, from 1 to 15, you calculated count 1, count 2, count 3.
This is the
Yeah,
main program. Okay,
program.
and this
Yeah.
is a procedure definition.
Okay. I'm confused about the order. So which means first it will
First
make a
count
group of
one.
Chennai, Bangalore, Vellore.
First
The,
count one will execute. Okay, first this procedure will execute for the entire scores data set, regardless of the cities.
okay. Yes,
Okay.
correct.
So whatever valid number of study pairs are there, that will be stored in count one, regardless of cities.
Yes,
Then
correct.
the line 2 will execute. Okay. So we'll again go through entire study scores data set and divide the students into 3 piles who are from Chennai, who are from Bangalore, who are from Vellore. Those 3 types of students will be divided into 3 different piles.
Yes, correct.
Now line 14 will execute once the piles are done.
Okay.
Then line 14 will call the study pair procedure 3 different times for these 3 piles. Okay. So it will give the
So,
valid number
but
of
the
study pairs for each
where it
city.
no, madam. Now here the pair study pile Chennai.
Hmm.
How it is stored in this actually Chennai? So this how it will take the memory actually. Steady pair pile Chennai.
So
So
it will
where it is
store it in
stored
some
actually?
temporary location. Okay. It will not store it
Oh,
directly in count to some temporary location. It will store it until the rest of these two are calculated. Once all three are
okay,
calculated, then the sum will be stored in count two. So then the temporary locations will be erased.
okay. Understood,
Okay.
madam. Okay,
Yeah.
understood.
Okay. So yeah, let's keep it up to here. So I think 4 questions more are left from practice. So whoever takes the next class, you tell them to complete those 4 questions, whatever is left in practice, and the activity questions. But from week 4, practice and graded is the main important thing. Activity type of questions will not come in your exam. Okay, those are just 1-2 marks question. They don't come in exam. But to understand the concepts better, you can go through them once. Okay. So I'll stop it here. Yeah. Thanks for joining, everyone. Have a good night.
Thank you, ma'am.
Yeah.
Thank you, ma'am.
Thank
Thanks.
you.
Thank you, ma'am.
Excuse me, ma'am.
Yeah.
Ma'am, when would be able to see the centers for our quiz?
That I don't know. You can ask the support.
Sure.
Yeah,
Thank you,
these
ma'am.
things are handled by support, so you mail them. Okay.
All right.
Ma'am, is there any website from where we can practice more questions?
Website, so I don't know. You can get PYQs from your batchmates, or you can ask your seniors. Maybe they might help you. They might have some more materials. But
Okay, so
actually,
we
this
don't have.
computational thinking, if you want, there is a book. Okay, that is given in the, I think, course orientation. It was somewhere it is given. There is a book. So if you can get the PDF of that book from there, you might get more questions. But as of now, like this type of pseudocode based questions, it's difficult to find online. Okay, you can find for a
Okay, ma'am.
programming language, but pseudocode is not as such given.
So if I practice all the graded and
This is enough. This is enough.
this
Just
is
do the
enough.
practice and graded. Yeah, enough.
Okay, okay. Thank you, ma'am.
Yeah.
Ma'am, hello.
Yes.
Ma'am, in exam time, which type of question it will come, like lengthy
Whatever
or?
you're getting in practice and graded assignment, that type only.
Okay, ma'am.
Yeah. All right. I'll close the session now.
Thank you, ma'am.